Hey guys, this is the fourth video in our Unit 4 note series on the arrangement of the periodic table. This one might be a little bit longer than the last few, but that's okay. If you need to go back and rewatch it, that's what it's here for. We're going to talk about how the table is arranged in more detail than what we've already talked about. So we've had some intro to that and kind of built the foundation for what we're going to get into today. So let's jump in. We're going to be on page 8 in your notes. And the first piece we're going to talk about are periods. Okay, so the periodic table is made up of periods and groups. You've heard those terms before. You've probably done your vocab at this point, so you have some understanding of those. The periods are the horizontal rows. Okay, so they're running from left to right. So you can see here by this picture. Okay, this is period 3. Right here, potassium all the way up through krypton. Okay, so what I want you guys to do first, as a good review, because it's been a while since we've done those things, I want you to go through the element symbols, or based on the symbols that are here, and I want you to give me the name, the group number, the electron configuration, and then the Lewis diagram. Now remember, if you're not sure, well, what's a Lewis diagram, right? The full name is Lewis dot diagram or an electron dot diagram. Okay, so we're going to do one together, and then I want you guys to go through and review those on your own. So, K, hopefully we know what that is. That is potassium. That is found in group 1. Do you remember what group 1 is called? If you thought alkali metals, then you would be correct. If you look on your reference table, potassium has a 2-8-8-1 configuration. Okay. Now for the Lewis diagram, it's been a little while maybe you remember it, maybe not. Think about what you have to do here, right? Lewis diagrams, electron dot diagrams, they show the valence electrons only. So if you take a look, we'll change up colors here. Valence means outer one, so it's the last one. Potassium has 1. Again, it was in group 1, so hopefully by now we can kind of start seeing that. So there's just 1 dot with it. So I want you guys to pause the video at this point, and I want you to go through and do the rest of this chart. If you have questions about it, just have me check it for you and in person. All right, so continuing on then, that should be done. No, I'm not going to put the answers on the video because I don't want you to just copy them. So remember, octet, that term is a big term. That means you have a full valence shell. Okay, outside is full, 8 electrons. All right, what we're shooting for, except for period 1 elements. Now think, how many elements are in period 1? There's only 2. All right, you've got hydrogen and you've got helium. The first principal energy level, remember we talked about that in the last video, PEL, can only hold 2 electrons. Think 2n squared. All right, so when you plug that in, first energy level, it can only hold 2 electrons. Therefore, they're going to be the exception. They're stable with just 2. Okay. And that's what here. So for whom 2 electrons marks a full valence shell. Kind of the way to remember it is 8 is great. Okay, 8 is great. That's the magic number. The only exception, like I said, are hydrogen and helium because they're in the first energy level. Okay, so let's continue on. Now, we talked about periods. They're running left to right. Then we have groups that are running up and down. They are the vertical columns. So you should at this point be able to know and start calling them groups and periods, not columns and rows. Now you may think about that in your mind, and it's a good way to remember it, but know the terminology. Okay, know the terminology. Now the other term that's associated here with groups is also families. Okay, sometimes they're referred to as chemical families, and we'll talk about more about why that is as we go into detail. So same thing here. I want you guys to go through, all right, write in the element name. So first one, we've got hydrogen. We've got the configuration. Oh, that's easy. It's just 1. And then it's going to have just the 1 dot. So Pause the video, go through, complete the rest of this on page 9, have me check it in person. Once you've done that, go ahead and work on the table basics here, kind of summarizing the last two videos that we've gone over. So these are some good questions that you could be asked on your Regents exam. All right, let's continue on. Let's talk about groups more in depth. So group 1, you should know by now, alkali metals. For these other videos, go ahead and check the classroom. They should be in the Unit 4 section, or as well as on my YouTube channel. They are under the Unit 4 playlist. Okay, so check those out if you haven't watched them already. When we talk about the alkali metals, again, because they're families, if you think about you and your family, right, or just in general, typically a lot of times families have similar personalities. Okay, same idea here with the periodic table. They all have one valence electron in the alkali metals. So think about it. What's the magic number they're trying to get to? 8 is great. They're trying to get to 8. Is it easier to lose 1 electron or gain 7 more to get to a full one? If you said lose, you're absolutely right. Alkali metals easily lose their 1 valence electron and they become +1 ions. Review question, what's a positive ion? What's the name there? Make sure you know it. You've got to know that terminology. They are extremely reactive. If you paused this video and watched the other one, you can see just how reactive they are. So if you haven't done that, pause this video at this time and go and watch the 2 videos that I have there about the alkali metals. Group 1 contains the most reactive metal. Okay, it's probably francium, but francium is so rare that we've got to just say cesium for the sake of it. Okay, if you can find francium, it's definitely going to be more reactive, but cesium is more common, so that's what we kind of think about. So those are the alkali metals. Group 2, we've got the alkaline earth metals, again, family. They all have 2 valence electrons. They prefer to lose their electrons as well. Again, think, is it easier to lose 2 or gain 6? It's definitely going to be easier to just lose those 2. Okay, so they lose their 2 electrons. They also become positive ions. They're going to be +2 ions because they're losing 2 this time. And they are fairly reactive. They're not as reactive as the alkali metals. They're the ones that give you the biggest bang for your buck. But they're a little bit reactive, but they're never found alone in nature. So groups 3 through 12, those are your transition metals. They are in the middle of the periodic table, known as the D block. We didn't get into that, so don't stress about it. These ones form colored ions in solution. If you think back to the flame test lab, if you specifically think about copper and cobalt, copper was blue in solution. Cobalt was that nice reddish color that you saw. This concept of colored solutions, all right, is always on your Regents exam. Star this in your notes, highlight it, make sure you know that transition metals, they form colored ions in solution. They tend to be unpredictable. That's one reason why they're called transition metals. Okay, they can form different numbers of bonds. They don't just form the same number every time. It depends on what they're bonded to. They also form multiple charges. If you look on your periodic table in your reference packet, I'm going to go ahead and pull it up here. If you look here in the middle, most of these, a lot of them, they have multiple oxidation states, which are just charges. We'll talk more about those later on in the year. That's where you see a lot of multiple ones, where if you look at group 1, oh, they're always +1. Group 2, they're always +2. So we'll talk more about that when we get to redox chemistry later on toward the end of the school year. So those are our transition metals. Let me zoom out, sorry. They are the least reactive group of metals. They are most likely to be found uncombined. Oops. In nature. Think about it, guys. What do we use? What types of metals do we use to build things? Okay, we use things like copper for plumbing. All right, we have gold for jewelry, silver jewelry. You've got iron. All right, that goes into a lot of stuff, and you don't have to mix it with a lot of stuff because they're pretty stable. All right, they're not super reactive. Groups 13 through 16 BCNO groups, that just comes from boron, carbon, nitrogen, and oxygen. They're kind of miscellaneous groups. They don't really have, one specific family. Okay, they have metals, they have nonmetals, they have the metalloids in those found along the staircase. They have a lot of different properties. So there's not just one specific family that we can call them. So they're just kind of miscellaneous depending on where they are. All right, two more to talk about. Halogens, very important one. That is group number 17. Okay, they have 7 valence electrons. Now think about it. Do they want to gain or lose? 7. Is it easier to gain 1 electron or lose 7? It's easier to just gain 1. So they are very, very greedy. All right, so it's easier. They like to gain 1 electron. Therefore, they're going to have negative charges. This is where you start to see those. And we'll talk more about charges, like I said, rest of the later in the year. So don't stress too much about it right now. Remember, 8 is great. That's what they're trying to get to. They form a lot of salts, which salts are just ionic compounds. We'll talk more about that in our next unit on bonding. All right, and they are called halides. Halide salts. They contain the most, you could think about it being reactive, but it's not in the same sense as those alkali metals. It's just the most active nonmetal, which is fluorine. They are all made up, or the entire group is made up of all nonmetals. Okay. And they have 3 states of matter actually found in this group. You've got solids, you've got liquids, and you have gases. All right, and it kind of goes from top to bottom. Fluorine is a gas at room temperature. Chlorine is a gas. Bromine is one of the only 2 liquids on the periodic table at standard, atmospheric pressure and temperature. And then iodine is actually a solid. Okay, so an example, we could just pick out chlorine for an example of one of those. Okay? And the last family we're going to talk about, they are the noble family, the noble gases. You've probably heard that term before. They are noble because they are unreactive. Okay, so this term inert, make sure you know this term. I know it wasn't in your vocab, okay, but make sure you know what inert means. They may throw it to you on the Regents exam. They have a stable octet, meaning that they have 8 electrons in their outer energy level already. Sorry, the lights went off. They are the most stable group. Again, because everybody's trying to get to 8, these will exist alone in nature. The only exception to the octet rule is what? What do you think? I already talked about it here in this video. It's actually going to be helium. All right, because it only has 2 valence electrons because it's in that first energy level. So, example, neon. Now, hydrogen is not officially a part of a group because it's both a nonmetal and it's a gas. It reacts a lot of times like those alkali metals, which is why it's put over there in group 1 a little bit. But it has many different forms. You could have it as hydrogen gas, which is very flammable. Think the Hindenburg. You could see it as an ion, a positive ion in solution. Later in the year, we will talk about those when we do acid and base chemistry. You can also see it as a negative ion. We'll talk about how that differs when we do naming. And then there's the lanthanides and the actinides at the bottom. They do belong to the transition metals, okay? But we won't really talk too much about them or use those in this class. So I know this was a little bit longer. Make sure you know the properties, know where these groups and families are, and then we will continue with that in the next video.